Hello guys, I am Kavindra. In this video, I am going to talk about half adder and design it with Logisim. Let's go to the video. Let's consider this as a full adder. You can see there are three inputs, but half adder there are only two inputs, and the third one is carry in. In here, I indicate it as the CI. So output both are same as half adder. Those are sum and carry out. And here I indicate it as a CO. The basic thing is in here full adder added these three numbers together and give sum and carry out. Let's see truth table of this full adder. You can see there is a three input columns and 8 rows. Because of 3 input, when we put it to the 2 to the power n, we get 8 rows. So this is output column sum and carry out. The simple process of this is A and B added together and added Ci to it. Likewise, you can understand all additions in this truth table. Let me explain one row. I am getting this row. When firstly A and B is 0 and 1. When added 0 and 1, it is output is 1. Then that 1 and that Ci1 added together, then output is 2. That means 1 and 0. You can see the carry out is 1 and sum is 0. I explained these things in previous video, so I think you can understand this. Let's see the equations of this full adder. You can see here sum is equal A XOR B XOR Ci. Likewise, this is the carry out equations. Using this equation, let's design full adder with Logisim. Okay guys, you can see this equation here. Let's design our circuit. Firstly, I am get three inputs here, and I need to I labeled it as A, but I think I need to change these directions. For that, I go here and set it to south. Then I also need to get this label upside. For that, here we can see label location, set it to north. Then you can see we can draw our lines like this, and I need to copy this 2 3. The reason is we have three inputs. I labeled this as a B and labeled this as a CI. Okay, now I am drawing these lines below for our easier. Now, first one, A XOR B. Let's design that thing. Let's get XOR gate, put it here, set it to 2 input, connect A and A XOR B. Now XOR C, that means we need to get output of this. This output is A XOR B. Now let's get another XOR gate. I am copy and paste it here and set it. I am connect this to here. You can see I am connected this one. Then set it to CI. So you can see what am I doing. I give in this input as the A XOR B, and here I give CI. Now we can get this equation equal. We can get this equation. Now we can set it to our output sum. label this as this, label it as a sum. Now our this first part is completed. Let's go to this part. Let's design this part first, A and B. So for that I am getting AND gate here, set input to 2, then connect A and B. Now it is, this part is also completed. Now let's go to this part. You can see here A XOR B. We can simply get A XOR B from here because we created it before. Now here we need to AND gate. Again AND gate, copy paste and set this input to here, A XOR B, and we have to send Ci through this. I connected Ci here. Now our this part is A and B. I will A and B, and our this part is Ci A XOR B. Now we need to add these things together. For that we need OR gate. We use OR gate and set it to 2 inputs and send these inputs. Now set it, I named it as CO. Now you can see our circuit is completed. Let me finalize it. Now it's look like pretty, okay? So now our circuit is completed. Let's simulate this. For simulate we click here and you can see it is working. So let's put 1 1. It means carry out 1. When we go send 1 1 1, that means 3, it is indicate 1 1. So you can see it is working. Let's see truth table of this. For that, go to the project and go analyze circuit. So you can see here our truth table. Let's compare this thing with our previous truth table. So you can see the both tables are equal. So that means our circuit is perfectly correct. So this is the thing I need to explain you in this video. Thank you for watching this. See you in next video. Have a good day.